12th. Oh, sorry. Welcome everyone to the November 12th, 2024 session of TAPR and HamSCI technical session. My name is Dave, KV0S, and this week I've been cleaning up the shack. I got my printer working and doing some tasks, 3D printer. And I've been going through and reorganizing my radio, my K9Q radios. So trying to make a little more sense out of the jumble of wires on my desk. Anyway, next on the list, we have Nathaniel, W2NAF. Go ahead, Nathaniel.
Thank you very much, Dave. I appreciate it. Let's see. Things have been. Oh, hold on. I was wondering. Okay. Yeah. Thank you very much, Dave. I appreciate it. Things are going fine here. The big thing this week is I'm going to the NASA Citizen Science meeting that's held in Leesburg, Virginia, and I'm going to be meeting Gary McKeaton and Gareth Perry there this week. And Gary has he will be showing, he's prepared a table. There's what's called the showcase. So HamSCI will have a table there. We now have a new HamSCI newsletter thanks to Ed Fchek and Mary Lou West and the graphics designers and print shop at the University of Scranton. It's very glossy, so we'll be bringing copies of that. And we have so that's going to be this week. I'll leave Wednesday. I'll be back Friday, so I should be back next Monday night. And then next week, Tuesday through Friday, Gareth and I are both on the Cedar Science Steering Committee for the National Science Foundation, so we'll be flying out to Boulder, Colorado for that. So we're trying to do this in addition to keeping all of our classes going through the end of the semester. So it's keeping us busy, but we're pulling through. Back to net.
Very good. Next on the list is Andrew on the iPhone, but I don't know if Andrew has voice. Go ahead.
Hi. Um, uh, I'm Andrew. I haven't been doing much lately. I bought a couple of ESP32 chips, and I'm going to try and work with them and see if they have any application that might be of interest to ham radio. Just about to get started and plug them in on my days off coming up. That's all. Thanks. Back to net.
Very good. Yes, there are lots of opportunities to use those chips with ham radio. Next on the list is Bill Engelkey, AB4 EJ. Yeah.
I'm working on a variety of things. Probably what's of most interest to this group is figuring out the calibration of the great version 1 DRF. And let me share this screen here. Right. All right, W1XP, Bob, helped me out by using a calibrated signal generator and then putting in a bunch of different signal levels, which you see here, starting with, I'm not sure what he started with, but it was saturation. I think he started mine maybe with minus 35 dBm. And then you can see how well, the upper one is the way our legacy plotting software handle this, which uses a linear scale. But if you convert this to dBm and then plot it using dBm, I converted all the signal values first from the values that come from the A to D converter through the system into the sound card and then into DRF, and then convert those to VRMS, volts RMS, and then convert that into dBm. And so you can see how we get a whole lot more detail in the amplitude plot. I think this lower level one is something on the order of minus 99 or minus 95 or so dBm, and then he turns it off, and the rest of it's just noise. So at the lower level, you see getting some noise superimposed on the signal because the signal coming out in the signal generator is so small. Anyway, I realized that this applies only to the Grape 1 DRF system. We don't have such data for the RX 888. So I would love it if somebody would take a calibrated signal generator, and you see how W1XP has done this. In order to be able to look at it on this chart, you need to leave the signal generator at a variety of different signal levels for about an hour each time. And then I can plot this, and then I'll be able to see what kind of numbers come out of the RX 888 because they are completely different than what comes out from the uncalibrated units on the Grape 1 DRF. For example, on the chart there, you see it runs from 0 to 1.2. The RX 888 comparable values run 0 to 7,000. So obviously, there's a completely different scale in the signal chain between the input and what the system finally puts out after going through a variety of different processing steps. So I would love it if somebody would do this for, well, I really need it for the RX 888 as well as the Grape version 2, which will allow me to plot these charts correctly, because when I read a system value, I look at an observation, I know based on the station that submitted it and what instrument they were using, the calibration factors for that instrument. So we would like to be able to provide, and this is very interesting for Gwyn's research. He was the one that started me down the path of getting these into actual numbers rather than just uncalibrated units. So that's the highest priority thing, and also preparing to import over 66,000 files from Grape 1 Legacy and Grape 2 systems up through October 20th. And we're going to have to work on how we transfer everybody who is submitting data via existing magnetometer boxes and Grape 2s, so that we get them submitting to the personal space weather station network. And to figure that out, because I'm just always playing a role of catch up, trying to import files from WWV Club Server and Linode and other places like that. So anyway, thanks. Back to Net.
Okay, thank you very much.
Bill, I
Next,
have some questions. Can we do that
go
later?
ahead, Phil.
Yeah. Sorry, I don't understand what the signal processing chain is here, because I've already calibrated KNIQ radio on the RX 888. It reads absolute dBm on the antenna terminal now.
Okay, well, what would 7,000 dBm be? I can calculate that.
7,000 dBm?
No,
Yeah.
no, 7,000. These are a sample value of 7,000. Whisper Demon sets the when has been last few weeks sets the AGC values so that it picks it up at the start. So there's really no way to say what the absolute RMS value is, because I have at the input of the RF input, because there's two stages of AGC. Well, there's this need to fit within the wave file range. So what Whisper Demon does?
By looking, you're looking at the wave output. Okay, well, yeah.
We're
If you
talking
look
that
at
he's looking at the wave file sample range, and
okay.
and Whisper Demon in the newer, for the last month or so, what it does is when it starts up, it looks at the signal level in the wave file and says, how do I adjust the channel gain so that the samples likely fit within the wave file.
I
So
understand doing
I
your own
set it.
AGC. Yeah.
Okay, so that's what the AGC does. And the AGC sets the channel gain so that the level is about 6 dB below the, the peak level, dB full scale in a 16-bit sample. So that's why you're seeing 7,000, which is the sample value, is something like 6 to 10 dB below the peak value, which is the 64,000, well, 32,000. So is the peak value for a sample in integers. Right? Those are integer numbers you're reading out. It's 7,000. The samples in a WAV file, right, are 16-bit samples, so they range in plus or minus 32,000. So I picked that value so that if I'm and left the channel gain constant on these WWV channels, so that it's unlikely that you would see a series of overloads, because previously we were seeing serious overloads in the
Yeah,
so
but I
this
mean, if
is
you want to know
so
absolute RF input, I mean,
To cut to the
unfortunately.
chase, is there a
it's all
readout
traceable.
of received signal strength available?
Yes. Yeah. I've been
But
trying to say that. I mean, you can
exactly.
trace that right back to the antenna terminal.
Well, you need to know what the RF gain and the channel
All
gain
you
is
have to
in order
do
to
is
get
look at
back.
my meta information. It's all there, updated several times a second.
Yeah, yes, but there's no place to put it in the personal weather station database. There's no place to put the channel gain. So the numbers for any one of these are not meaningful because we don't know what the gain is from the SMA input RFS to the wave file. There's no way to communicate that information
Well, I mean, you can
in
put
the
it
way
into
now
you've
yeah,
got
so
metadata. You can put it in the metadata of the DRF.
please tell us how to do it, and I'll be happy. The data is there. The Whisper Demon and Phil's code tell us, give us that information. So we know the total channel gain. So the information is available, but I'm using going into digital RF format. I depend upon what Franco created a Python program, and I take the wave files and I give it the wave files and Franco's code comes back with the digital RF data that we upload to your server, Bill. But I don't, maybe we need to enhance that. Franco hasn't been joining our calls, but it's his code that does that translation. And it's in Python, which is a language I don't really understand. So I don't know how to modify SCA. Yeah.
Rob, Phil says the number is there. We just have to
Yes, the
put it
number is
into the
there in the status
metadata.
channel.
Where do you
gain,
put it?
whatever
Well,
it is, you can use a reference gain. If you set a gain, you will already know exactly what the connection is between the RF output sample and the antenna input power.
So I guess what he's asking, is there an API somewhere where it tells it where you put that data in the files you're uploading to the Grape server, and are you using it?
I don't know about it.
I mean,
I didn't
that's the
create
question.
that software. I didn't create that software. So it's,
How do you attach that information into the file you're uploading to the Grape server? And more importantly, does the Grape database, can it use that information?
Well, that can be added.
So the answer is no.
yeah,
Right
the answer is no.
Okay,
Yeah.
So
I'd be happy to work on it.
Yeah.
I'd be happy.
I mean,
I'm happy to do that. But
So what
the
you're
first
saying is the
stage
problem is not on my end. The problem is
no,
not on my
no.
end.
It's not. No. All the information's available.
All
Bill.
right.
You give us all the information. The
All right.
problem
That
is
wasn't clear.
the problem is the creating the digital RF format data that we upload to Bill. That I don't, Franco didn't include, and I don't know if there's a definition for how to include the RF gain and channel gain information into that digital RF format data. I'm sure there's a way to put this in, but I didn't work on that. I depended upon Franco. So Franco created a Python program
All right.
that takes
Scott,
away.
N5TNL is saying Wave 2 Grape has the metadata added to the DRF file. You just sent that on the text on the chat.
Okay. Yeah.
Well,
Can we
All
get
right,
back to
go
the
on,
roll
go
call?
that
on.
goes around, and if somebody
Just go on.
wants to talk to him, all they have to do
Yeah.
is ask, as I've been in
We should
contact
probably
with.
talk about this later.
Okay. Okay, let's go on down the list. Let's see. Next on the list is Jim, K4BSE. Go ahead, Jim.
Good evening, all. Well, my big achievement this week is fixing as best I could an error I made when I put my magnetometer in over a year ago. I couldn't get the magnetometer in quite 3 feet. I'm missing about 5 or 6 inches of being there. And when I assembled the pipe, I forgot to put insulation in the pipe above the magnetometer board. So I was taking more temperature variation than I thought I should in the wintertime. So I decided the best thing to do would be to build a cage over it out of wood, build a wooden cage on top of it and stuff as much insulation as I could in that cage. And then I would have the whole thing kind of insulated. And I got that running. I think I got the insulation in it on Saturday. So that's done now, and I hope that it'll give me a little bit less bad day to this winter than I had last winter. That's about it from here. Back to net K4BSE.
Okay. Next on the list is Bob, N5BRG. Go ahead, Bob. Bob there? And no response, so we'll go on down the list. Next is Clint, K7OEI. Go ahead.
Hi. Well, been upgrading stuff at the Utah SDR. At some point, it might be worth considering putting one of the new packages, or at least the magnetometer or some subset of it at Utah SDR, since it is in the middle of a cow pasture. But working on mainly what we were working on were power systems. In the past couple of months, we've been getting anywhere from 0 to 300 volts, where 120 volts should be at random times, and that does not bode well for equipment. So we're trying to beef up the our power system and also increase the runtime. So less RF, but more just actual getting your hands dirty with hardware stuff. But we're starting to work on rolling the. We're getting close to starting to roll from whisper reception on Kiwis to just 888s. We've had a test system up for using an 888 for about a year now, and we've decided it is stable enough that we could probably trust it. So that's what I've been doing, and sometime in this coming week I'll get my 630 and 2200 meter stations back on the air, because I had them off for the winter. So I will pollute the lower frequencies as well. So back to you.
Well, very good. Next on the list is Dave H, W6OQ. Go ahead.
Yeah, good evening, everyone. As usual, I'm just here trying to absorb as much as I can. But for Bill, I want to mention that the Grape 2 hardware has 3 level settings in it in the RF path. So I don't know if you're taking that into account, or if that matters on the grapes that are DRF. Anyway, that's what I have. Thanks.
Okay. I was wondering if Bill had a comment, but
Well, yeah, I mean, we're gonna have to get John Gibbons involved in this, and Kong is gonna have to work with, I mean, right now, Kong has got software that converts the grape raw data into DRF, and it's going to have to go in the metadata there. I mean, it's relatively simple to add it, but we just have to do that. I mean, I'm a long way from figuring out the calibration on the grape too. I'll be happy if we can get it working for the RX 888.
On that particular comment, I believe we do report our jumper setting.
It's in the metadata somewhere, Dave?
I think so. I'd have to go back and look at the display, but I think we're supposed to report what jumper setting we're on.
We just have to figure out a way that Kung can get that included into the DRF metadata. I mean, DRF is really made for this, that you can have an almost unlimited amount of metadata, but you just have to agree on what you're going to collect and what you're going to call it. So.
Okay, well, next on the list is Dave New, WB8 SBE.
Yeah, that's N8 SBE.
I keep making, I'm sorry.
That's all right. We're just operating as the fly on the wall here, and my other hobby is taking up all my time during the day right now, which is photography. There's a Photoshop, virtual Photoshop summit running the entire week. So that's occupying a lot of my attention right now. So.
Okay,
Yep.
very good. Next on the list is David McGaw in one HAC. Go ahead, David.
Hello, everyone. Been playing around with rheometers this week and trying to figure out if my site is quiet enough for these types of measurements. But we'll find out. It's quieter than the lab, I'll tell you that much. We're trying to do, as I've mentioned, a relamping project at the lab, but even if we quiet it down, it's not going to be suitable for that. But it's an ongoing thing, and I am very interested in this reported received signal strength coming out through the hardware and software, because I'd like to be able to plot signal strength on a particular channel. In this case, I'm listening to 30 megahertz at about 100 kilohertz bandwidth or something like that, looking at noise. Hopefully there's no signal there. That's the whole point. But we're looking at the galactic noise. So interested in the conversation, and back to Nat.
Okay. Next on the list is Doug, KF0PCW. Go ahead.
Hello.
Clint, your mic's open.
Oh, sorry.
I'm operating on fly in the wall mode as well. Something I've joined this week is planning for the HamCon convention in Colorado, which will be at the end of October next year. So a question I have, does HamSCI go to district conventions of ARRL, or would there be any interest in that?
I can't speak for HamSCI.
Oh, TAPR?
Or TAPR. TAPR, we're still in a process of getting reorganized after several changes, and I can tell you more about that in another couple weeks.
Okay.
But
HamSCI does go to the New England district convention.
Okay. And I'm sure if you contacted Nathaniel, he would be happy to have you show up representing HamSCI if you want to.
I'd be happy to do so. I'd
Yes.
like to have a more senior member with me.
Yes. Well, Nathaniel has left us because of, I think, his baby And
Yeah.
also,
So where are you, Doug?
So I'm in just outside of Denver, and so I was just wondering. I know there's some people in the area that I can contact, like Dave Schwartz, maybe.
Oh, yes, absolutely. He's
Yes.
involved with us.
So I'll contact him.
Yes.
But we'll certainly be interested in anybody else who might want to come over.
And there is a division convention for ARRL there?
Yes, it'll be in Grand Junction, the October 23rd to the 26th.
Yeah, excellent. Yeah, I'll bet Dave
Okay.
would be very much willing to help that with that.
I'll contact Nathaniel and
yes,
thank you.
very good. Next on the list, let's see if I've missed. Okay. Jamal. It's here.
Hello, everyone.
Jamal, are you able to speak? Yep.
Yes, I'm here. Hello, everyone. Good morning. I just want to thank the Giants who gave me the nice feedback on last Thursday presentation, specifically Dr. David Magao. I'm still digging in the rocks to get some results from FarLab, and I hope finally it works. Thank you.
Okay, thank you very much. It's like 2 in the morning, 3 in the morning for Jamal.
Yes,
so
it's 4:27
oh,
a.m. right
4,
now.
sorry.
Oh.
But that's still, you had to get up to do that.
It's crazy, yeah.
Yes. Let's see. Next on the list
Silly round
is
world.
yes. Gremlin. Gremlin, any comments? No comments. So next on the list is Jay Schwartz, WB8 SBI. Go ahead, Jay.
Yeah, good evening, everybody. Nothing new spectacular here in the metropolitan Detroit area. Just starting to get my travel gear together for the Radio Club of America convention, and I'll be in travel mode, so I will not be participating in anything HamSCI next week because I'll be in New York. So with that, I hope anyone who's coming there has a safe trip. Hope to see you there. And take care, everybody. 7-3, back to net.
Enjoy your trip. Next on the list is Joe, W7LUX. Go ahead, Joe.
Good evening, everyone. The two grapes are working well. I've been doing some asteroid occultations and trying to get a spectrograph running. Thank you, Dave.
Yep. Thank you. Next on the list is Jonathan, KC3EEY. Go ahead, Jonathan.
Hi, everybody. I've been kind of occupied with some non-VLF related matters, but I'm slowly getting back into it. Last week there was a discussion, after hours discussion, you can say, regarding the HamSCI antenna selection and its use of an earth-ground connection. So that prompted the issue with electrical isolation that was necessary for the VLF system to operate. The VLF receiver and the interface inside both utilize isolated DC to DC converters for power and audio isolation transformers. And then when I was made aware that the HamSCI that some of the candidates for the HamSCI antenna selection project utilized an earth ground connection, obviously made made my ears perk up, because that obviously isn't galvanically isolated, and it has to be galvanically isolated for the VLF system, and not necessarily for any sort of interference coming from the shack. But obviously that would help. So this is something that I would like to discuss further, with the possibility of adding isolation to the preamps of any antennas that are chosen, because even something as simple as using a mast, like a metal mast, and the shield of the cable electrically connected to the metal mast will create a ground loop, and it could potentially pollute the site with ULF and ELF noise coming back from the shack. So if the antenna, so any antenna that is sited near the VLF active antenna, no matter what it is, there has to be isolation, and we can't have any sort of ground loops, even from the shield of the cable, or the power pair. If a power pair is used to power the preamp, but we have to make sure that that's isolated. And if it's not, then there's a good chance that the VLF system won't work. And we want to, and since the grant obviously talks about having these co-sited together, this is something that we should keep in mind. And I don't really think adding galvanic isolation to the HamSCI antenna would be a big issue, or impact performance, especially with the right sorts of isolation. So this definitely needs to be. I do feel that it needs to be discussed. And then lastly, Clint, I noticed that you mentioned that one of your antennas in Utah is sited directly inside a cow field, and I thought, well, that would be an excellent site for a for one of my VLF active antennas. So please keep that in mind when the time comes. That would be a great site to have a VLF system recording data. Lastly, there was the Abilene.org site. That was the site that monitors, or that has a bunch of data from various VLF receivers, including ours, and it was down for almost a month, but Paul got it back up and running, so it's currently up and running. It's not currently recording and logging data. Normally he's logging about 100 days worth of data. This is obviously Vorbis compressed data, but it's up to 16 kilohertz also, but it's but right now he just has the signal monitors running and the event detectors running, so you can look at the various events that were captured, which there was which the most recent event was a Whistler. That's all I have. Back to the net.
Oh, okay. Next on the list is Phil, K9Q. Go ahead, Phil.
Hey, everybody. Let's see. Yesterday was fun. We went out to the desert to recover some balloon payloads that the kids launched in the high school the day earlier. It was a little longer than we expected. It may be flat, but it certainly isn't easy to walk on when there's a landmine every couple feet, being, gopher holes and such. It's incredibly quiet out there. It seems like it's not always a great place to do astronomy, which we've done before, but I'm beginning to wonder if it would be a great place to do radio stuff because it's away from everything out there. God, it's so noisy here. Let's see. Last week I tried the frequency measuring test, but I kind of blew it. My PCM record program isn't handling metadata correctly, and it recorded the IQ data incorrectly. So I'm going to fix all that, test it, and try again in 6 months. Other than that, that's about all I have here. Back to you, Dave.
Oh, okay. Next on the list is Scott Newell. He's usually mic muted. And also we have Tom Ask, AC9L. Go ahead, Tom.
Yeah, hello everyone. I'm a fly on the wall here. Also, very interested in astronomy and connected with University of Illinois some years ago with the W9YH station. So good to hear what you guys are discussing, trying to keep up. Thank you.
Well, please, if you enjoy the discussion, please come back.
Thank you. I was here once before a month or two ago.
Okay. And next on the list is Rob Robinette. Go ahead, Rob.
Well, we could resume talking about about channel gain issues and calibrated wave files. I made but just as an aside, I made a stab. I was hoping that I could use. I thought there's a new Ubuntu. Maybe it works better on the Orange Pi, and so I squandered some of my development time trying to get an Orange Pi to work. And once again, it turns out it drops packets inside the kernel TCP stack. So it's just the Orange Pi. It's such a shame. Otherwise it would be a perfect platform for us, but I just could not get it to work. As soon as the CPU got busy, it started to drop packets, IP packets. So I'm let's see. Mostly we can, a bunch of others, much of my own projects, nothing really other than that. Well, let's see, antenna project. But let me take you guys aside. We've been talking about antennas, and I really took to heart Jonathan's concerns last week about the ground loop problems introduced by the DX Engineering field probe, and took a look at what the alternative using Glenn N6GN's active dipole, and I think that I don't want to. I would love to use a product that's available commercially, and perhaps we can work through and add the the RFI suppression and the ground loop suppression needed, and make the DX engineering work. But Glenn's active dipole is does have really a lot of attractions, and I'm showing you this is his dipole running.
What we're seeing is a
Oh,
mail
wrong.
list.
Oh, well then, hold on a second. I didn't. Zoom misled me. Hold on. Share. This one. You should be seeing. Here. Okay, that's highlighted. You seeing that? No. This is of Kiwi
Yes.
SDR.
That looks
being
like a Kiwi SDR.
spectrum. This is a 0 to 30 megahertz spectrum. This is at Glenn's site, which is line of sight, but 16 kilometers, but line of sight to the WWV transmitters. And so this is his current generation of his prototype. And a couple of things to note is that that he's not seeing overload, but if you want to look at the say the low frequency, let's go down to 10 kilohertz. All right, this is a 0 to 10 kilohertz spectrum, and so this is a fully balanced system. There's no ground loops introduced. This is a vertical dipole, active vertical dipole. And so it does not introduce ground loops, and it has response. Well, Glenn didn't, as you can see from the roll off of the noise. What we're seeing here is if you look at, I think the 18, 20 kilohertz, there's an 18 or 15 kilohertz. This is coming from an Australian um, submarine transmitter site. And this is the various submarine transmitters that are around the world really being picked up here. But you can see that the background noise level rises as one would expect, although there's the response really goes down. If I go down to 1
You can
kilohertz.
almost pick off the time off the 60 kilohertz.
Oh, easily. I mean, it's well, of course, he is 60 kilohertz is he's only 16 kilometers from the WWV transmitter. So obviously it's very strong. I mean, he's getting at it. This is easy to get, but
and what
hopefully
bit per second you could probably pick it off by eye.
Well, I've put in a few averages here. So if here, there's no averaging now, so you can.
I think we're seeing it second harmonic too. There is a built-in WWVB tone code decoder in here.
Well, there is. Well, that's in any case, you can see the second harmonic. But if you go down and look at the really low frequencies, like let's go down to 1 kilohertz.
Yeah, in the 20 kilohertz range, that's pretty good.
Yeah.
It's picking that up. I can see NAA, which is all the way over on this side.
I see Loran C is back.
So you can see if you
it is in parts of the world, yes.
Yeah.
Unfortunately, not here.
So if you zoom in, you can actually see that. Whoops, here you can see the 120 hertz and its harmonics that are being picked up by who knows what. Bridge rectifiers in the neighborhood is probably the source, or there might be some way Glenn needs to improve it, but you can see that even those are extremely extremely low. But so potentially it seems like this might be useful for ELF as an ELF antenna. But in any case, it's a fully balanced antenna and gives us response from 1 kilohertz at least to actually it goes up into the 2-meter band. And compares favorably with his disc on the same fence. So Jonathan's observation last week renewed my interest in including Glenn's antenna in consideration for our deployment. It involves, of course, we'd have to make it and assemble it and deploy it and support it. So those are all things that are just as soon not. I think we would just as soon not have to do, but the performance of the antenna and its and especially its not introducing problems with ELF, and potentially even be useful for ELF. Seems like a reason to reconsider it. So as an aside, my friend Elmer, a member of my Whisper Demon circle, has ordered 5 of these prototypes. So of this antenna. And
which antenna is this, Rob?
This is Glenn's N6GN's what he calls the single antenna. Let's see. open source hardware. Here's this field probe, but let me go
Right.
back here and I'll show you what the antenna looks like. Whoops.
Well, I mean, I think Glenn would agree, but an antenna that is designed for ELF and VLF would not use the same design parameters as one optimized for
One would
HF.
No, that's actually not true. I mean,
Well,
a
I
lot
mean,
of these E-field antennas have this kind of response.
right, but I'm talking about issues like if Glenn has to jump through lots of hoops to keep broadcast stations out of stuff. So if you live
surprisingly, these parts that he's using, he's got a 50 kilowatt AM station 5 kilometers from him.
Right.
And he's actually not seeing the active parts. The active antenna parts are not getting overloaded by it. He puts filtering after them. There's filtering in the system.
Right. But I have a hard time believing that you could get adequate 1 over F response, 1 over square root of F response.
It seems like
that would be good at Schumann frequencies versus 30 meg with the same device and the same.
It is that's what surprised Glenn. That's what surprises Glenn too. It surprises Glenn. It appears that it may. There's only.
Yeah, well, like for example, I could show it, but we have a active E-field whip that I've decoupled at Utah SDR, and I'm getting a lot better SNR at VLF. I mean, below 30 kilohertz than what I'm seeing on Glenn's.
As I say, it's just a possibility, but it does have response down there. There's reason to think that it certainly eliminates the ground loop problem.
Well,
okay.
Yeah,
it does.
But to me, comparing what we have at Utah, it doesn't look very good down. When you get down really low, it doesn't look very good. But I think
what design do you have at Utah?
What
design do you have at Utah?
It's actually relatively. It's up at 30 feet, but it's on a tower. But it's just a single-ended E-field whip that's been decoupled from everything else.
So what's its front end?
It's actually it's a Russian power JFET.
Yeah, well, that's what a lot of them are
like one of the 510 watt JFETs. It's one of those. I mean, it's sitting there like dissipating like 3 watts all the time. Yeah. But anyway, but I think the problem with the balanced antenna, at least it's probably a matter of scaling. I mean, Glenn's requiring differential signals between the two E-field probes for his to work, and since I'm decoupling it, even though it's connected via coax, it's being decoupled from everything else with lots of inductance on the feed line. And so we don't really pick it up.
Well, his can work against ground as well. It doesn't have to have a second dipole.
It is working. Right. But I mean, but the Glenn's antenna is a relatively physically small E-field whip, and getting enough nanovolts or microvolts across, a 12-foot piece of 12-foot dipole at a kilohertz is not insignificant.
This is a 5 meter dipole, so it's a little more, it's a little bit. But as I say, I'm not saying this is a solution. All I'm saying is that to the E-field, the ELF problem. But it renewed my interest in considering this antenna for the other bands, the higher bands, the grape receiving, because it would now, of course, the alternative is use the DX engineering and figure out how to suppress the ground loop effects that it might introduce into the E-field antenna. So those are the two.
Can I?
Go ahead.
Before you all get completely lost in this
subject, which I suspect could go on a bit. I'm not going to be able to stick around. I was not called on in the roll call, and
I'm sorry.
there's just one quick thing I wanted to mention that might have some interest for someone. We came across a bug in the KA9Q web software this last week. John Ackerman was trying to use it across a VPN of some kind, some commercial one that I'm not very aware of, and it was failing utterly. And it turned out to be easily fixed. It needs a second S in the startup string for the WebSocket, to make sure it's a secure WebSocket. But apparently, some of these commercial, I guess it was a VPN. It's nothing I ever heard of, but it was refusing to allow the connection to the K9Q or to the radio. I don't know. It was refusing to open the WebSocket proxy. And there's this particular line in the code. Franco may have put a note in the collection of it that he has put on his, in his GitHub. I've been working with the code otherwise some, but it's still pretty unlovely in some ways. But this is just something that might bite someone, and someone could get in touch with me if they hit a snag, or Franco, because John, I guess we fixed it completely for John, and or told, and so that's all I had to say.
Okay. I'm sorry, Dave, that I missed you on the list. Names were jumping around, and I obviously made that mistake. And I think I've called on everybody now, so we're open for general discussion. So nobody wants to talk.
I've had more than my share, so I'm shutting up for a while.
Oh, Bob, N5BRG didn't get called on because he wasn't answering when I called him the first time.
Yeah, I'm
Bob,
here.
are you there?
I don't have anything to report. I was fumbling around on my computer trying to hit the right button and knock myself off.
Oh, okay.
But, anyway, I'm here, and I'm here for just a few more minutes too. I need to get out of here early.
Bob, have you fixed up your AAA? Did you get your AAAs and fix them up?
I haven't fixed them up yet. I did receive them, and that's on my to-do list here is to get those put together.
Okay.
Finding little problems with computers and
okay.
I
just wanted to alert you that the it's very easy to install the thermal pads and slip the PC board in if you follow my suggestion. But if you use what Paul puts on his website currently and use a putty knife, that's not a good approach. Just it's difficult and stresses the printed circuit board. So just I've encouraged Paul to update his instructions on his website, his installation instructions.
Okay, I won't use a putty knife.
But don't use a putty knife, okay? Just you don't need it. There's a little piece of plastic on the thermal pads that I sent you. Use that clear plastic as instead of the putty knife.
So I noticed I took one of them apart, and I noticed a small thermal pad on one of the units.
They come with They come, yeah, you have to, when you slide it out, when you pull the printed circuit board out, there is a small thermal pad, but it's nowhere near enough. In,
So
in
you just
fact,
take that off and use a
yeah,
smaller
I just remove that and put the much larger one. In fact, the major source of heat is not the the ADC where they put the thermal pad. The major source of heat are the linear voltage regulators, and so they're the ones that need to have the thermal the heat dissipated, and that's one of the
Okay, well, thanks for the tip. Yeah, I'll be putting that together pretty soon.
So Rob, thanks for bringing that up with the discussion of the various antennas. Nathaniel and I, early on when we were installing the VLF system, there was the possibility of two orthogonal HF loops being sited close by to the VLF antenna. So what we did was we purchased isolation transformers that will operate it into the VLF range without much loss, or the HF range without much loss. I forget what part number that we chose, but but Nathaniel has, I believe, 6 of them, and I believe they were like close to $100 a piece at the time. But so what I was thinking about was the possibility of, since we use an active preamp, of course, the use of an isolated DC to DC converter, but testing will have to be done to ensure that isolated DC to DC converter doesn't actually interfere with the HF signal. But if we could find one that would not interfere, I think that would be useful, as well as the possibility of using an isolation transformer. So this way we'll have full isolation from the shield or the ground of the feed cable, and that's kind of the most important thing here. And I would also like to hazard that not only would we need isolation at the antenna site, it may be necessary to have the isolation on the other end too, similar to the way that the VLF system is. But again, we would have to test that. I haven't really looked at these antennas in detail, so I really don't know the inner workings of their preamps or anything like that yet. But I think those should be options that are worth investigating. Particularly.
Well, yeah, I mean, the problem is you can put, it's easy to put isolation transformers in the RF feed lines, but if you have DC power going out there, then you have to suppress, suppress the common mode effects of the DC ground.
Yeah, there are
And
two
all
ways
that
to
can
do
be all
that.
that can be done, but it's just adds complexity
Well,
to the.
Well, but Jonathan routinely does a DC-DC converter to isolate, but you can also just feed it AC and rectify it at the preamp. In fact, a lot of antenna preamps, like TV preamps, did that. They didn't do it to isolate it, but they sent AC up the line.
Mm-hmm.
Could easily.
Well, I'm not saying that it can't be done. I'm just saying it just needs to be included in the,
By the way,
the design of the whole system. So.
I'll show you another E-field probe. This is what we flew on our rockets. They're still flying, but it's 2 globes, 60 centimeter spheres with active preamp in each one. And this sits on the nose of the rocket. And its primary purpose is to pick up plasma waves in the like between 100 kilohertz and 5 megahertz range. But this was flown on the Viper sounding rocket, which its primary purpose, its primary experiment was to pick up to NAA, 24 kilohertz from Cutler, Maine. We flew it from Wallops Island. And this did remarkably well, picking up that signal too, even though it's not very, the separation isn't very much, but it actually does pretty well picking up VLF, believe it or not.
So I guess I'm not clear when we're with reference to personal weather station or whatnot. When they talk about the VLF receiver, how low are they planning to go? Like Schumann low, or just spheric low, or what?
Spheric low.
Okay, so you're talking about a kilohertz or two.
I'm
at the low end.
Yeah, I'm starting. So my receiver captures 60 hertz quite well, but we don't go as low as the Schumann resonances, because that's kind of like a whole nother ball game. That would be like a whole nother VLF receiver. But I'm mainly interested in spherics and any and all VLF, ULF, ELF natural radio signals. So, but I usually consider anything above 100 hertz as usable.
Oh, okay. Yeah. All right. I would just.
Yeah. Well, there are a number of things to be done with VLF, because there are the actual natural emissions, which Jonathan seems primarily interested in down in the, hundreds of hertz to kilohertz range. But then all those transmitters in the tens of kilohertz are of great interest, because they show solar activity, among other things.
Yeah, my VLF receiver is also capturing those, all of the VLF transmitters, and the software that I use, it has the ability to accept a full spectrum, and it will actually spit out amplitude and absolute phase information from multiple VLF transmitters, depending on how you configure it. But it'll actually, you could generate plots of every VLF transmitter. So it's very versatile in that I'm not only capturing the natural radio emissions, but I'm also capturing VLF transmitters as well.
Right. Yeah. Okay. Yeah, I've been doing this VLF thing since the 80s, so it's always been an interest in me. But yeah, this is what we're seeing in northern Utah, actually. So, and this is I don't know if you're familiar with them, but have you ever seen those? You don't see them anymore, but they're decoupling chokes used for analog video to keep the 60 hertz out of them. And there's 3 of those in line here. And that is how we can get away with having grid referenced information stuff on one end and practically no coupling of our power system into this end. We even have we have a room full of switching supplies and inverters running, and we really don't see them at this time. The only one is one that occasionally shows up around 20 kilohertz that fires up, and as we identify those, we remove them by filtering, because we have a special filtering boxes. We're constantly watching for things to show up. When we add new gear, we look at the whole spectrum and see if we can see it showing up. But as you can see, it's achievable to get something pretty quiet, even though we have a half a mile or a mile away some pretty high tension power lines. But the stuff down here, the Kiwi really falls on its face below about 5 or 6 kilohertz. So anything below 10 kilohertz, I'm not sure I would trust the Kiwi at all. You can feed audio into it and tune in there, but it's really tinny and really bad. So anyway.
Yeah, do you think you're seeing the 1/f coming up down below there?
I think it possibly. If you disconnect the Kiwi, if you disconnect an antenna from the Kiwi, you still see some stuff coming up over on the far end. I don't know exactly what's on the bottom end. For all I know, it could be the 1/f of the voltage regulator we're using. We're using a 7818 to feed this, and I haven't gone through the exercise of trying to clean up below 15 kilohertz yet.
Yeah, they're not the quietest.
No, I did some. I had a powering some PLLs, and I actually had to put a emitter follower decoupler on it, which completely cleaned them up. But I had to do that to make them on a PLL. It was adding a little bit of phase noise to a PLL, and I just had to add transistor, resistor, and a capacitor, and it became undetectable. I haven't gone through that exercise, but yeah.
Now, I hadn't heard about the Russian FETs. I know about the crystallonics that AMRAD.
Yeah, the Russian ones are comparable and maybe a bit beefier. And at least before the Ukraine war, you could just get them regularly, but they seem to work every bit as well.
Now, I found some major size FETs, not quite that big, and they're in TO92 package, but
right. These are stud mount.
Yeah, oh geez. There's a 2SK152 that I discovered in one of my Radio Shack shortwave receivers, portable receiver. It regularly blows out, which it had. That's how I got the receiver. But it has remarkably low noise. It's like nanovolt per root hertz, which is quite good for an FET. And then there's another number, 2SK170, that's supposedly even better for audio. I've got a bunch of them that I'm going to try making preamps around. But most of these are used in things like J310s and such, which are fairly small FETs.
Yeah, so
they're about 4 nanovolts.
Yeah, I have a couple here. I'm looking at I just dug them out of my parts thing, and I don't know if there they are.
Oh my goodness!
Yeah, they're the number on them. The Latinized number is KP903, but it's not KP. It's some whatever the Cyrillic equivalent of it is.
Yes.
Do I have that written down? I don't know how quiet they are. I don't know that the CP666 and all that is super quiet, but then again,
they are.
But yeah,
that's the whole point.
Well, yeah, Bob Pease is fond of using JFETs and front ends of really parallel JFETs because the bulk noise. Every time you square the number of JFETs, you have the noise. And I developed an extremely low noise optical a baseband receiver years ago.
Right.
And I used the BF863, if you're familiar with that device. It's a Philips device. Yeah, that was a remarkable one. Unfortunately, it's no longer made, but I think there's a rough equivalent. But
none of the good stuff's made anymore.
yeah, this stuff. I don't know if you can get these KP903s anymore. I mean,
the bean counters keep saying, "Oh, the sales are too low."
well, I mean, these are. Let's see. I wonder if there's probably date codes on these. I mean, these are probably 80s, 90s date codes. I'm guessing. I mean, there was a time after the Soviet Union fell where all the factories, electronics factories, just cranked up production to the max because they were still getting money. And so all this stuff got produced in warehouse, including tubes. These have a 1985 date code on them. It's K, and it's a thing that looks like an upside down U, 903B. That's the but yeah, I had in the antenna I had to put a heat sink. I bolted this to a chunk of copper because it does run toasty.
Well, the upside down U is a pi. It's the letter pi.
Well, but it doesn't have the little flourish on it.
Right. But that's where P comes from.
Yeah, yeah, probably, yeah. Yeah, you probably know your classic stuff better than I am. Yeah,
a little bit. I mean, I'm not versed in Cyrillic, but I know where its origins are.
Yeah, they're rated for they're rated for 6 watts.
Wow.
Yeah, and the zero bias drain current is 600 mils. So go figure.
Yeah, I know there are audio designs that parallel tons of FETs for their input, but you got to match them.
Right. Yeah. So we've had this antenna up for years now. It does have a low pass filter in front of it because we get massive. I mean, there's this huge salty body of water between us and 3 or 4 50 kilowatt AM transmitters.
Mm-hmm.
So it has a very sharp 500 kilohertz low pass filter on the front end, super high impedance, and it's not perfect, but it does the job. But anyway, but yeah, if I can find them, I'll show the what we're using to decouple the coax.
So what's inside my design is actually a op amp. What do I use? The 86. No, I can't remember which one. One of Analog Devices, low noise FET op amps.
Sorry, I realized when I got halfway into the other room that I had the volume up really low. It's what inside your design?
It's Analog Devices low noise FET op amp. I'm trying to remember which one I used.
Oh, okay. This is for
I'm gonna.
This is for a VLF or just LF?
Well, it's our primary on this experiment is HF. We're looking at 100 kilohertz to 5 megahertz plasma waves up in the ionosphere.
Okay.
And but I designed it for to go low, and we actually got useful data out of it on this flight. I don't know why I'm spacing that. I'm going to look it up.
Okay, these are what I've been using. These are what I use to decouple LF antennas, VLF. These are these are removed from a analog production environment where when you ran analog video cables from one end of the building to the other, you end up with hum on them. So these have oomph on them to get rid of 60 hertz. And they're about 3 dB down to 30 megahertz because they have a lot of, they're 75 ohm, but they have a lot of, just a lot of small diameter coax on this very beefy, probably, I'm guessing it might, I don't know if it's a soft iron or ferrite. They're semi-potted, so I don't know exactly what material's in them. They weigh like 3 or 4 pounds. But they will, they have, I don't know, let me figure out, I can measure it here. I figure out what impedance they have at 120 hertz. I have a ROC meter here.
Yeah, what I used was the Analog Devices. Oh God, I just forgot it again. The 8065, 8065. And there's an 8067 that has higher gain. It's uncompensated if you want higher gain at the hot HF. We didn't need it. Those are pretty nice low noise pet op amps. Good workhorse.
Right. Yeah, these have 63 ohms of resistant impedance at 120 hertz, but I don't have any way to measure anything else. But these are used in combination with some higher, like dozen turns on a 31 toroid.
Did I see that was Utah?
Yeah, different ones, different companies made it. These are the HF 1057 by Utah Magnetics, and
right.
A bunch of different companies made similar ones. This is the only one I could lay my hands on immediately, but I have in my shop, I have a box of these things.
No, I remember those.
Yeah, they're now the vaguely similar thing you could you used to be able to buy you used to be able to buy these devices that would let you put analog security cameras on Cat 5.
Right.
And those had a very similar thing in these. It was a common mode coaxial transformer. They were much smaller. They didn't go quite as low, but they actually worked surprisingly well. And it'd be nice to be able to find a bunch of those transformers, because those would make excellent decoupling transformers for just generalized HF. I mean, they're old school. They have like millihenries from end to end, and they're a teeny tiny package. They're a little lossy, but generally on HF you can put up with a couple dB. But I mean, they were for analog on Cat 5, and that's how they did it. At the low frequency end, it was you're below the cutoff. I mean, you didn't have enough reactance to make them effectively balanced. But when you got into the hundreds of kilohertz and megahertz, then it was effectively balanced because of choking, and I installed a bunch. I have a box of those. Actually, I have a box of those actually somewhere. We installed them in a high rise, 25-story high rise back in the 90s, where we had security cameras, but we didn't have a lot of room for cables, but we had a lot of Cat 5, coax cables. We had a lot of Cat 5, so we could put like 4 security cameras on a single Cat 5. They barely, they really didn't bother each other, but these are all analog. So
yeah. Of course, Cat 5's not supposed to crosstalk.
Yeah, it's not supposed to. When you're running 600 feet, you do get roll off.
You get a little bit.
That's a bit beyond spec, I believe.
Yeah, I mean, you can make it work. Yeah, one of the people I worked with, they needed to transcode off-air video down to the basement, and what Ollie did was he piggybacked a off-air DMOD with a modulator and cranked it up and stuck it on Cat 5 and got to the basement just fine.
You guys ever heard of fiber?
Well, yeah, but I mean, this is like, we need this next week. I mean, this is like late 90s.
And
Okay.
this, you don't have to convert anything. You're putting raw video onto the.
Well, this is
Cat 5.
actually RF. I mean, they bumped it down to like channel 2 and cranked up the level.
Oh, okay. Oh,
VHF and cranked it down and cranked up the level and got it downstairs.
They stuck through a RF modulator and took it down that way.
Yeah, yeah.
Oh, interesting.
They demodded it and remodded it. Actually, Tongue used to make these devices that would take off air and then convert it at 8 IF, 45 meg IF, just to a different RF channel.
Right. So they were on different frequencies.
But they didn't actually demod it all the way. They just simply, down converter, stall filter, converter, and amplifier, and that's what they were. And they had built-in AGC, and we had an in-house cable system for that, and we used a whole rack of those to spread it around the building. We eventually did get coax distribution in there, but when it was newly built, feature creep. Like, oh, we want people to watch TV as well. Okay. I wish you told us that earlier.
Yeah.
Anyway.
Of course, you could have also just used the cable head-end modulator.
Well, yeah, but these back-to-back ones are.
That's what I use for amateur television.
Oh yeah.
You can there are a couple of channels that fit in the 440 band.
Oh yeah, 57.
58, 960.
Yeah. I ran an ATV repeater on 42625 for many years.
Yep.
So.
I wanted to have a real vestigial filter on it, so.
Yeah, I have one that I
cable head in.
I have a transmit one built like this, welded aluminum. Yeah, but yeah, I have all the stuff in the garage to put something up on 8 VSB. Well, either 8 VSB. I guess I could do either 8 VSB or I'm drawing a blank. It's the current. Let's see. It's the old MPEG satellite format. They're up to. I mean, it was QPSK. Now they're up to 16 QAM or something like that. DVB-S,
right.
have S2 and S2A and whatnot. But anyway, I spent most of my career as a chief engineer for satellite teleport for data and video. So, I haven't done that for years. So, start losing what you knew. But anyway.
Yeah, the FIFO only holds so much.
Yeah. Anyway, I've been, I've had in the back of my mind at Northern Utah a means to have good ELF, and the approach I would probably take would be more of an oldie but a goodie, and it would be stick a post. We have out. I could probably the farmland goes like a mile or so that we're on of the same landowner. And we could stick a pole in the ground high enough that the cattle won't knock off what's mounted to it. And then I was thinking of just having it solar powered and just modulating ELF as audio onto a wideband FM carrier. I mean, then that thing would be wirelessly transmitted over and then it'd be dirt simple to demod at the other end. I mean, if it's good enough for the search and rescue satellites, it ought to be good enough for this.
Hey, what's available in the form of field portable VLF antennas? Is that a practical thing?
Oh yes, very much.
Because I'm thinking, I've been out in the desert yesterday. The place really is quiet. I mean, you're miles from anything.
Jonathan's stuff, you can carry it around.
Does the name Steve McGreevy mean anything to you, Dave?
I don't think so.
Steve McGreevy, okay. Yeah, I don't know if he's still around, but in the 80s and 90s, he wrote a whole lot of articles for the LWCA Lowdown. And also a few of them found their way into more popular print on mostly spheric monitoring. In fact, there's a short film, you can find it on YouTube, I think called Magnetic Fields. And in the background, it has, they're interviewing these scientists at some sort of superconducting research facility, but the background soundtrack is spherics and whistlers. And superimposed kind of on the video, you see magnetic lines of force. I have to see if I can find it. But background, the spherics are all, I believe, recorded by, I think it was Steve McGreevy. I couldn't remember I can't dredge his call from my memory at this point. But he had some, I can probably find him in my old, in my archives, some, 80s, 90s vintage portable ELF, spherics type receivers. I've heard spherics a few times, and what the most mysterious one, though, I was listening on the 630 meter band of all places, and I heard what sounded for all the world like spherics barrel through the frequency, which I have a hard time believing because I have a hard time believing spherics would be that obvious at 470 kilohertz. And
by spherics, you mean whistlers?
Yeah,
right.
Right. I mean, I've heard them before, and this is exactly what they sound like. But this is I was in the 630 meter band listening, and
that's a
not
good
an
question.
Iona sound or something. Yeah.
No, not that low.
No, they wouldn't be that low.
I didn't think so.
Right.
They start above the AM band.
Yeah, 3 to 30 or something. The one I have was 3 to 30. But yeah, I was shocked. I mean, they went on for about 30 seconds, and I didn't quite get the. I was just kind of idly listening in the background just to see if a signal I was listening for would pop up. This is right around sunrise, and I didn't get the presence of mind to start the recording until they had passed. But it was a little before local sunrise. So, but half a dozen, barreled through the frequency. That sort of, what?
Yeah, 630 is what frequency?
472 to 479 kilohertz.
Okay.
I wouldn't think whistlers would be that high, but then again,
Yeah, that's a good question. Whether it would take a pretty high magnetic field to have it up at that frequency, but
how do these? I don't know the physics. How do they get through the D layer, or do they just not do it in the daytime?
Well, I don't know how they're affected by the D layer. They're so low frequency.
I mean, a whistler is basically a lightning strike that's been propagated a long way around through
well,
a very
yeah, I mean,
recursive
right,
path.
between the poles.
Yeah.
Actually, my start in VLF came from Stephen McGreevy. In fact, he it was so I was actually building this was like a personal project. It was a WWVB clock, and in doing various research, I came upon whistlers, and then I looked into whistlers because people said that they were these mysterious things. So that's what kind of piqued my interest, and then from there, then I found Steve McGreevy. I listened to his recordings. I read a lot of his articles. Really, really good stuff. He's observed things that were in academic papers that he probably didn't even read, but since he did this so much, he was able to observe. Like, for example, he was able to notice that you tend to get more whistlers after a geomagnetic storm. Why that is, I'm not exactly sure, but that tends to be the case because after geomagnetic storms, at my location, I noticed that I tend to get more whistlers. So it was so he was observing these things, and he did like many variations of his portable VLF receivers, because that's kind of what he specialized in. He kind of specialized in portable VLF receivers, going out into the wilderness, and listening for these things. And he has hours and hours and hours of recordings of dawn chorus and whistlers and spherics. Actually, if you look on archive.org, he has various albums called The Music of the Magnetosphere, I believe. And many of his recordings they initially start with the pulses from WWV to timestamp them. So he was able to roughly timestamp his recordings by injecting WWV into them. He actually sells, which I purchased back in 2013, the WR3. That's his portable VLF receiver. It uses a JFET front end, and an LM386. It's primarily made for personal listening. He also did a design called the BBB4, and that is the design that I actually built. I purchased his WR3, but the second VLF receiver that I built, I built based on the BBB4, and it's very easy to build. I was able to put it into a Hammond enclosure, and I used a whip antenna as a probe. And what I was able to do with that, this was back in 2013, I added an output so I could record on a digital voice recorder. I also added another output so I could pipe it into the microphone input of my iPhone and view a live spectrogram as I'm listening to the whistlers. Thanks, Clint. Yep. And so, and I also had added a headphone output with an LM386. So I mean, it was him. He kind of started everything for me. So and I've emailed him a good a couple times, and then because initially what I was going to do was I was going to go out to these locations and listen for whistlers, but then I found VLFRX tools, and then I found Paul Nicholson also would go out to these locations, and he would never hear any whistlers at all. Not even one. And you could go months without detecting a whistler. So what he did was he created various software utilities that will take recordings from a sound card, and he's able to actually pick out the Eckersley curve of the whistler and the rising frequency components of dawn chorus. And he wrote a separate program that it looks for that in the spectrum, and it'll create recordings of each of those events. And that's what I run on my VLF system, and that's what you can actually see on his website, abilene.org. So that's kind of how it evolved. I initially started with Stephen McGreevy, his portable VLF receivers, and then from going out to the wilderness trying to listen for these events, seeing Paul Nicholson's software that could automatically listen without having to go out. And the nice thing is with Paul Nicholson software, you can listen live. So my VLF receiver is actually live streamed on the internet, and you could listen to it live. It incorporates a mains tracking filter, so it filters out the majority of the mains hum. So it actually makes it listenable. It makes the whistler detector work quite well, and it could be streamed over the internet. It was last April, and I was laying in bed. It was like 4 in the morning, and there were whistlers coming through like crazy. And normally I would have to be out in the wilderness listening for this stuff, but with his software, I just happened to have it streaming on my phone, and I was listening to it in my bedroom, laying in my bed, nice and warm. Don't have to worry about the weather. So you can not only listen live to the stream, but you could also listen to, or you could also automatically capture these events, which kind of led into this HamSCI VLF receiver system, where we could capture these VLF events. We could capture amplitude and phase information from VLF transmitters and have all this data freely available. So yeah, I would invite all of you to look at his receiver, especially his BBB4. Phil, if you're interested, he's also on eBay, and you could purchase a circuit board that you could put into a enclosure and build your own personal VLF system. You could probably also email him and ask him that, hey, if you don't want to do that, I just need a VLF receiver. He could build something for you for a fee. I don't know, probably about $150. But if you didn't want to do it yourself, but yeah, being in the desert, Phil, having a portable VLF receiver is a vital tool. In fact, that's how I evaluate the site where I'm going to put any sort of VLF receiver. Is I actually listen to my portable first, and listen to areas where you have the least amount of hum, and usually that's where your best place is if you
It's
want to.
interesting this, we're talking all these esoteric FETs, and it uses a 3819.
Yes.
Which isn't a bad FET, but
no, it's not a bad FET, but it's certainly ubiquitous.
I mean, that's essentially just an impedance converter. I mean,
right.
Yeah,
I mean, that's all you're really doing here.
Right. Yeah, coupling into the ether.
But of course, what you get with these more esoteric ones is lower noise.
What's the dimensions of the antenna elements? It's effective. I mean, are these things easily transportable?
1 to 3 meters. All he uses.
Okay.
Telescoping.
3 meter, 1 meter will do a good job.
Right.
Oh, yeah. So you can easily pack it up in your car and go.
Yeah. Essentially, you're coupling the free space capacitors to 50 ohms or audio amplifier.
Right.
That's all you're doing.
As long as you have a very low noise receiver, you can put up with the inefficient.
Well, it doesn't really need to be all that low in noise, because I mean, you think about it. You know what the electrostatic gradient, like 10 meters above the Earth's surface is. It's like it can be on a clear day. It could be kilovolts per meter.
Right, I've heard that. Yeah. Why can't we use that for power? Is what I want to know.
Well, you can, but you get
very, very little current. Yeah.
Well, I mean, well, as a for instance, though, during Civil War, they had a wireless telegraph. And you know how they did it? What they did was they, like a couple miles each apart, they would fly kites, and one guy would have a galvanometer on his end, the other guy would have, a couple of miles away, would have a key shorting to the ground, and unless there's lightning or something going on, you could actually see the guy keying the kites, with a couple hundred feet of wire from kilometers apart.
I guess I didn't know that, Mark. How
Yeah,
you
it just
get
sort of
that stuff?
modulates the free space. You have
Yeah,
a
I guess it
kite
would
going up
work.
there
Yeah,
like several hundred feet.
yeah, it would work.
Yeah, it did work. I mean, they did use it some, that, and also the river telegraph, where they just had, a couple, wires, a couple hundred feet, upstream and downstream, and on the other side you could do the same thing.
Of course, the only problem with that is the balloon kind of betrays your position.
That's true. I mean, but it's portable and it's wireless, yeah. But yeah, but I mean,
Right.
so I put in the chat the link to the it's Magnetic Movie is what it's called, and
I saw it. Yeah, that's cool.
Yeah, it's yeah. I haven't talked to Steve since probably the 90s personally. I mean, we used to get on the Lofernet on 80 meters, and I wasn't even sure he was still around. It's good to know that he is.
Yeah. He's still he still sells his VLF receiver boards for people who want them. He sells them on eBay, and he also sold a stereo H-field loop.
Oh yes.
He sold it for a short period of time, and I was actually one of the few to actually get them when he was selling them. But and I have yet to actually try it. But yeah, he also was selling that. So for people who are interested in VLF and they just want to get started, I always refer them to Steve, because it's his all of his articles and his recordings are great for someone just getting started. But there's also other portable VLF receivers too. There's the Inspire VLF3 receiver that's currently being sold. That also works. That has a similar circuit as Steve's does. There's also the E202. If you go on, if you search Google, that'll come up too. Also similar design. They're all basically impedance converters. That's what my VLF receiver is. It's an impedance converter, and just as Clint said, it basically couples from the ether. You could kind of think of it like not as RF, but when you're analyzing these circuits and their performance, and if you want to model them, you would model them kind of like audio circuits, basically.
Phil, I'm sorry. I just wanted to ask Phil, could we tune the output of your radio D streams? Could we create a channel that mimicked a sound card, i.e., tuned to frequency 0, and just get
just tune a channel to 0 hertz.
Well, I mean, let's see. Well, you have one of the utilities. The last time I tried it, I pulled my hair out trying to make sense out of it, where you can take Linux audio devices and create a multicast stream. Which last I tried it, and it's been a while. I mean, it gave me a list of audio receivers, but I could not come up with a syntax that the program was happy with. You know,
Which program was this?
Give me a moment to look. It's the one that creates multicast streams from audio devices.
Oh, from audio devices.
I'm looking. I'm talking about having Radio D, tuning to something. You know, on Radio D, have the K9Q web, tune it to 0 hertz.
Well, yeah,
and shouldn't we hear the same thing as you get from an audio?
But the hard but the RX-888 is hardly the correct hardware for that.
Why not?
I mean, first of all, there's magnetics in the way. I mean, the 888 is essentially useless below a few kilohertz because, I mean, the transformer they have coupling the output between the VGA and the A to D converter is probably officially only good down to a few hundred kilohertz, and I imagine it's useful down to a few tens of kilohertz.
Okay. Well, that's a limitation. That's not an architectural limitation. That's an
Are you talking about my PCM send program?
That's probably it.
Yeah, I also have an Opus send. No, it takes standard input. That's what confused me. As you said, a device.
But,
so it takes
but as I recall, you can do a -I and it'll list inputs. Give you a list of input devices.
I wrote it a while ago. I guess maybe
right.
You're right.
And it'll give you a voluminous list, and it's like, what does it? It is like, what the hell does it want? Because I've tried it on machines with sound cards because that's an obvious one.
Oh yeah. I wrote this early on when I was specifying everything by hand on the command line, and
right.
Okay, you're right.
And I think you have since modified.
Yeah, those are. I think what it takes are Linux ALSA devices, ALSA.
Right.
Linux sound architecture takes those names, which they're a pain.
Yeah, I am painful. But will it take standard in as well?
I think you could. I think you could take standard in. I have to look at this thing. I wrote it a long time ago.
Yeah, I mean, because I've had an instance or two, and it'd be nice just like example, like VLF or something, where it'd be nice to K9Q compatible multicast stream. I don't think
I was using to send my receiver, hi-fi receiver audio around my network so I could listen to another room. That's what I did it for.
It doesn't support SSRC last time I checked. I don't know if you need it to, but but yeah.
Maybe not. Like I said, I wrote this thing a long time ago. I've not maintained it.
Yeah, I'm not sure it's useful with the present regime.
Yeah, well, I can take a look at it.
Yeah, because
old programs have a way I leave them in there, and I just don't keep them up to date, and then people surprise me by saying they actually use them.
I've used the Modulate program. I find that to be useful.
Really, use that one too, huh?
Yeah,
that one kind of went away with K9Q. When I gave up on the idea of having separate programs for handling the front end that would multicast the raw IQ output to a separate radio daemon, I gave up on that, and then Modulate became a lot less useful.
Well, what I've used Modulate, so in Northern Utah WebSDR, we have a remote controlled signal generator, and the way it works is it takes audio between, I think, like 25 and 48 kilohertz and up converts it to HF. So at various levels, it's useful. Like you want to test a receiver or something to make sure it works. But since it comes from a sound card, you can also just feed it arbitrary signals that you generate at, say 35 kilohertz, around there.
I do have a signal generator simulator now. It's now built into Radio D.
Right.
And it can even put a WWV emulator on a 10 megahertz carrier that you can tune into.
Right.
I should probably put it on all 6 frequencies.
There you go.
I wrote that WWV emulator when I got bored one day, and it's surprising how many people actually use it.
I wrote a WWV emulator to test some clocks. It was written in BASIC for a Model 100, Radio Shack Model 100.
Well, B's got a much simpler program. I do everything. Ticks, tone, announcements, all that stuff.
Whose voice did you use?
Well, for the station IDs, I got a clean recording from somebody
Oh,
off
okay.
the air. And for the minute announcements, I'm using one of the built-in audio synthesizers.
Oh, okay.
It's a little jarring, when you hear WWV's program, but then a total alien voice.
Yes.
And then some wise guy at a conference asked me from Canada asked me about CHU, so I went home and did a CHU emulator. The hard part there was finding a male French Canadian speaker.
Yes. Speaking Quebecois.
Yeah.
Yeah.
I found a female French Canadian and a male metropolitan, but no male French Canadian. Anyway, that was, a bit silly.
Well, I remember when you demonstrated that at the TAPR conference in 2019.
What, the WWV emulator?
Yeah.
Yeah. I remember I had it in 2017 because I used it during the eclipse when we were in Wyoming. I turned off the tones, just used it as as an audible clock. Of course, during the eclipse, all time stops. You get kind of caught up in the moment anyway. So
Yeah.
we got some good pictures. Kimberly got a great diamond ring picture through my telescope.
What I'm sharing on the screen here, I just wanted to show everybody. So this is what's running on my VLF system. This is VLF RX tools, so that the utility programs, it's a tool set of utility programs, similar to a Phil's package. And so the first one, VT card, captures the both these.
Yeah, that HW:0,0, that is an ELSA device specifier, just for Clint's knowledge.
Correct.
That's the kind of argument it takes.
Yep. So yeah, VT card has the ability to interface with either an OSS or ALSA device. So in most of the time, ALSA devices work actually quite well, and it basically just talks to ALSA to capture samples from the sound card. It's capturing at 32 bits, 96 kilohertz, 2 channels. The sound card that I use inverts the amplitude of the channels for whatever reason. So I have to invert it back. That's what the gain -1 is. And then I have it logged, of course. And then from VT card, it goes into a buffer called raw. So so from each program, what it does is it'll read from its input either a buffer, or in this case the ALSA sound card, and then it outputs it to a buffer called at raw. And VT time, what that does is that there's a GPS pulse per second signal on the other channel. Channel 1 in this case. Channel 2 is the VLF audio. This is the method in which that it looks for the center of the pulse, a positive going centroid. H is the whole is a holdover, and it listens to the raw buffer and outputs to the timed buffer. And then from there, then it goes into VT filter, threshold 5. That's the main tracking filter. Goes into channel 2 of the time buffer, and it outputs filtered. And then from there, it uploads. It's downsampled. with VT resample, it's downsampled to 32 kilohertz. Input is filtered 1, and then that's output to VT Vorbis, which it encodes the PCM audio into a Vorbis stream with built-in timestamping, and it's sent to a shoutcast source, so you could listen to it locally from a shoutcast server. It's also sent to abilene.org. That's the software that uploads it, or this will upload the Vorbis encoded stream to abilene.org, running the filter and the signal analysis and all that. VTCat copies it to a network socket, which it's sent to another server at the Fanless house, which it's basically doing the same thing as this, but as a backup. I also have the data written directly to a disk. So VT write writes to the stream to files on a disk. This is the location that it writes to. The file granularity is 3,600 seconds, an hour each file. I also have it for the 9600 or for the 96K data as well. The VT event, that's the program that will automatically look for whistlers and Don chorus, and if it captures those files, then it writes it to the events directory. And then VT-SID, that's the program that will monitor multiple VLF transmitters, and then write their amplitude and phase data to files, which can be plotted for looking for SIDS and things like that. So
Jonathan,
this is actually,
the theme here is actually more like that of GNU Radio than of my stuff. These are little piece parts that you glue together in various ways. And it's kind of more like the flavor of GNU Radio. I thought long and hard about this when I started KNIQ Radio about how much functionality did I want to put in each program, and what kind of IPC mechanism do I want to use. And so that's what I went a little different way. I put a lot of functionality in the Radio D, since you would usually want those pieces together anyway, and it would be more efficient to have them inside of a program rather than in separate processes. And then I decided on multicast as a way of making it easy to plug one input into many outputs.
Right.
The program you've got there called VTCat, I guess it writes to it's writing to a unicast address, not a multicast address. Can it handle multicast addresses?
It can't handle multicast addresses. What it does is it takes channel 2 of the timed buffer. So this is the time-stamped VLF stream coming from VT time, and it's copying it to this host here.
Using what protocol? UDP, TCP?
A TCP socket.
Okay, so there has to be something the other end, or this will bomb out or keep retrying or something, I suppose.
Yeah, so the other server is
the nice thing about multicast is that you can just send whether anybody's listening or not.
Yeah, this so this sends to that socket, and it doesn't necessarily it'll actually time out if there's an issue, but most of the time it runs without issue. So this is the VLF server that it's sending to. You can see here it takes the input from port 9000 and it outputs it to buffer called timed.
So, okay, nitty-gritty question here. When you
Mhm.
start this stuff up, what happens if VTCat listening is not already running when you start up the sender?
It will still it'll still keep retrying.
And what happens if the receiver goes away? Does the sender go away? What is it? I mean, this is the kind of thing, the hairy little details that matter when you actually try to run a
Yeah, no,
operational system.
the it still keeps sending, and if it does not receive a response, it'll just keep on sending anyway.
Well, it can't keep on sending. I mean, TCP won't let you do that.
No,
Eventually,
but it'll if it times out.
Yeah, I've piped audio to Netcat, and it just sits there and goes to dev null essentially if there's no connection. So it's like, yeah, I mean it's there if somebody connects to it, but if not, nothing happens. Literally, nothing happens.
Yeah. And well, I mean, you probably can't have more than one listener if it's a TCP connection.
No.
Yeah. And what happens if the listener is working and the listener goes away and restarts? Those are the kinds of things that get a lot easier when you use multicasting. You think about it.
I actually use for a CW skimmer, I actually use Netcat to get audio from a Linux to a Windows machine. That's really fun. But anyway,
yeah.
And Netcat just doesn't give a rat's ass. I mean, if the connection
if you
goes
only
away,
have one listener, then it's easy.
Yeah. Then when you reconnect, it just carries on as if nothing had happened. It's I mean, that's so.
If you only ever have one listener, that's fine.
And I only would ever have one listener. In this particular instance,
Well,
I found once you have the ability to hang multiple listeners, you suddenly find uses for it. Like I might have one program is recording the raw channel to a file, and another one is transcoding it and compressing it to Opus, and a third program that's listening to it, and so forth. Once you get the capability, you start finding uses for it.
VLFRX tools allows you to send to a limitless number of TCP sockets because it reads from the buffer. So it's what it's doing is it's reading from this buffer. So
I understand. It can be made to work. It's just
Yeah.
a little inelegant when you have a lot of listeners. That's all.
Yeah.
Sure, it can be force fit. It's just not the optimal tool for the job.
Right. Yeah. But this actually works quite well. I don't really have any issues with it, and other people who also use this software, they also send TCP streams elsewhere, and the way that I guess it was written is that it just
You don't find yourself you're restarting a bunch of programs and one of them hangs and stuff like that. I mean, that's great. I mean, it sounds like they've written it correctly.
That happened once, but that was when I was having issues with the time stamping portion.
Yeah.
So what happens is that it will it'll actually terminate, but then restart. This is what's in the log file.
Yeah.
But yeah, also on this server, I also have multiple SID detectors, which captures amplitude and absolute phase from like 17 VLF transmitters. I have another event detector running, a VT write, which writes wave files to a data store, and then I have a script running that FLAC compresses the data files and puts it on an external drive. And I also have so this is part of the lightning detector application of VLFRX tools. It's right now what it's detecting based on the impulse settings and the bandwidth, 6 kilohertz to 16K. It's looking for the time of group arrival for spherics. And if you have a bunch of these servers reporting data, you can have, say, if you have six of these systems running VT Toga and outputting data on the togas that it detected, you could actually do calculations on the location of those strokes. So that's also one of the things that I plan on doing with this network. But anyway, so if you wanted to look at, oh, well, you can't do that now, but anyway. Yeah, you can also look at your captured events. Well, I have to so the system will actually capture whistlers and dawn chorus. So this is a spectrogram thumbnail of the whistlers and dawn chorus that I captured. You could see these are the whistlers that I captured here.
Yeah.
And
What's the horizontal time scale?
yeah, 6 seconds.
Okay.
This is dawn chorus. This is what dawn chorus looks like. That's a riser. But
riser,
yeah, this is
huh?
These are tweaks, multimode tweaks, but these are detected because there was some sort of noise or something that created a false detection, but tweaks were visible. But yeah, this is dawn chorus right here. So anyway, and this is an example of like multi-band dawn chorus, where you have these risers on the around 5 kilohertz, and you also have some frequency content around 2 to 4 kilohertz. But yeah, this is so it not only creates this spectrogram thumbnail, but it also creates a wave file for each of these events. And the other interesting thing that you can do with this is, let's say that you were interested in a specific spheric. For example, let's say you had a friend that captured TLEs with his camera, and he had a GPS. It was GPS time stamped. You could look at the individual spherics in the time domain. So this is an example of a spheric in the time domain, and you can see the initial impulse right here, and then you can see a little bit of a ring out here after the initial impulse, and that's the ELF component of the spheric, which TLEs often generate spherics with an ELF component. It's not very visible here, but it depends on the propagation distance. So if I was looking at a spheric that occurred in Europe or somewhere very far away, that generated a TLE or any sort of lightning stroke with a continuing current, it'll have like an oscillatory tail. So you could bring up the time domain for individual spherics if you want to as well. And so this is just one channel. If you had two other channels input, which would be from a multi-channel loop receiver, you could have your other two channels as well, and not just one. And that's also interesting too when it comes to whistlers. But anyway, that's those are some of the capabilities
That's pretty
of
cool.
the software that I just wanted to showcase. And the plan is to have a bunch of these VLF receivers out in the field, and eventually having a lightning location network. So it'll be
Oh, so yeah, I actually right here I have a Blitzer tone receiver running. So,
yeah.
Yeah.
Yep. I
keep meaning to put it at the Utah SDR, but I need to get something farther away from the building. Here in urban Salt Lake Valley, I actually get pretty good results because I've decoupled my E-field whip. Plus, my house has a metal roof on it, and I can kind of get a cone of silence.
Yeah.
Yeah. Sort of a bubble. So it actually works better than most, even a lot of the ones that are located remotely. But I've also concluded that the default E-field receiver that comes with the Blitzer tongue really isn't very good at all. Its whip is way too short, and the receiver is deaf. So with it, yes, I tried it with it. Yeah, I even put the I also improved it greatly by adding. You can as an option you can get some Maxim semiconductor switch capacitor filters, low pass filters. There, that actually improves performance tremendously because the receiver is actually deafened a bit by around here it's Jim Creek.
Yeah.
I mean it just sits there and churns on, but I have the high pass or the low pass cutoff tuned just a smidge below Jim Creek, so it pretty much disappears from the waveform, and that improved the performance tremendously. Those two things. The thing that pulls my hair out about it though is it has option for one E field input or 3 H field inputs. But if any one of those receivers gets noise on them, it shuts them all off. It goes into the noise detection mode, like interference mode. Doesn't matter which receiver. You'd think it would shut off the receiver getting interference. No, it shuts them all down.
Wow.
So it's I've complained and but yeah, it hasn't been changed. But it generally works okay though.
Yeah. Yeah, I asked to be put on the list to actually be able to purchase hardware, and that was like back in 2014. So I don't know if I'll ever get it.
Well, I got myself on the list and right around that time, and I was on the list for 2 years, and then I finally got it.
Yeah.
So
Yeah, I
this you may have fallen up. There is a web page with the list, and I was like at number 900 something for like 2 years, and suddenly it's like, oh, 200. Oh, then like the next month is, do you want one still? And okay.
Oh wow.
I mean, I went from like 1,000 down to nothing, just over the period of like 6 weeks. But I stayed at like number 900 for like 2 years or 2.5 years. So I mean,
Wow.
you got to be patient.
Yeah, I'm sure
Yeah.
that they just make it in batches, and
Oh yeah.
it depends on funding. But related to that, I just wanted to show one more quick thing. I know that it's getting late, but this is this is the ILDN, the Indian Lightning Detection Network, and you can see this is a map, and here it's showing the detected strokes based on the color is based on their age. And so this system is based off of at least 10 receivers similar to the one that I use, but it also uses VLFRX tools, and it's application for lightning detection. If we go into the about section, so this is these are pictures of the actual system. And that's kind of where I got the idea of doing this. This is a signal processor. It's basically a Raspberry Pi, and the VLF receiver, or the VLF receiver interface, and a GPS receiver, and everything else. This is basically what I built. That's up at Nathaniel's right now. How in the world do I exit? But anyway, well, but you can see here, this is the VLF preamp, and the VLF active antenna, and the
You need to hit that little X up in the upper right corner.
Oh, is there a
upper right corner? Oh, upper right. There.
Oh, it's probably cut. Oh, there
That
it
is.
is. Yeah, it was. Thanks. Yeah, let me move this. Yeah, this is what the system looks like. This is what I plan on building, basically. This is the preamp. This is very similar, just an impedance converter. This is the DC to DC converter here. This is the audio isolation transformer. Front end, line driver. And this AC line choke here that you see, this is actually used to inject a calibration signal. This is this screw terminal here. You could inject a signal to actually calibrate the amplitude. So that's what this is used for here. This is an example of the antenna. and the system, well, he took it down, but there was a console screenshot with a bunch of VLFRX tools programs running in the background. So he has VLFRX tools running on the signal processor, and that sends all the toga information back to a central server, which is used to do the lighting location solutions and the mapping. And he uses a database and a post GIS extension for it. These are this is an example of events like I showed you. This is a whistler down here. These are the different locations. Obviously, this is noise that it's detecting. Yeah, this is an example. So this is kind of what I want to kind of roll out is something like this. The system status page gives information on each of the processors and things like that. He also has WWLLN data come in, I believe, as a comparison. Yeah, there's whoops. So you can also look at static maps. This is the last 24 hours, all the lightning activity here. And you could also do it. It also has interactive or GIF animations as well. So yeah, this is kind of what I want to do. But yeah, this all kind of morphed from first learning about whistlers, portable VLF receivers, to all of the work that Paul did on VLFRX tools and his VLF receivers. So that's kind of what I'm looking to do. But I didn't mean to take up everyone's time here. I apologize.
I think it's really interesting, and I'm thank you for the tour, Jonathan. I need to run, but I just wanted to ask Phil. I'm interested in how the AAA system would detect and listen to the same range of frequencies as your ELF systems, and I've tuned. This is one of Phil's systems. This is in Colorado Springs, and I've tuned to 1 hertz in AM mode. I don't know that I can share the sound if you hear it, but well, you can see WWBV up in on the right-hand side at 60 kilohertz. But I've set the tuning frequency. I set it to 1 hertz in AM mode, and
well, I mean,
this is
you're tuning in baseband, not 60 kilohertz, right?
what?
You're tuning baseband. I mean,
I've just tuned K9Q Reb
okay, zero.
to
Okay.
1 hertz to 1 hertz.
I see. There's 60 kilohertz up there.
Yeah, in AM mode, and you can see the Jack Creek or whatever it is, at 25 kilohertz, kind of in the middle. But you can see that the 5 kilohertz AM bandwidth is extending from essentially from 0 hertz up through 5 kilohertz. And
I've not characterized it that low. I ought to, because I have several 888s here now that work.
yeah, I don't know how, that the transformers, as you point out, probably, certainly limit the low frequency response. But it appears from looking at from the noise level in the background, uh, that the noise level is being modulated down there, down below down below 1 kilohertz, really. So
If I wanted to use K9Q radio for that, what I would probably do is I would build a simple converter that produced double sideband VLF up at like 35 megahertz or something. It'd be super duper simple.
what would you gain over what I'm doing right now?
Because what you do is you would have the proper hardware to receive VLF, then you would modulate it and upconvert it to where the 888 actually worked. It doesn't matter. It doesn't matter where I would frequency translate the VLF spectrum.
No, I'm just I'm just wondering how low is the 888 useful? It seems to be useful at 25 kilohertz.
From what I'm saying, it's probably not. Is this on Glenn's unit?
This is on Glenn's, yeah. So
is it the same antenna as the Kiwi was, or?
Yes, it's the same antenna as the Kiwi. Yeah.
Okay, because you're missing a lot of signals there.
I don't think so.
Okay. Yeah, you are. I mean, you should easily be able to see Cutler, Maine, and
let's go to the Kiwi. Here's
yeah, but anyway, a circuit that would take maybe say up to 30 or 40 kilohertz and simply translate it up to some arbitrary frequency, higher.
Of course, I know that. I mean, I understand that could how that would work. I'm just wondering what we get out of what we have right now without doing anything.
But okay. my point is if you try to make a receive system that covers ELF, a single bit of hardware that covers ELF all the way to 30 megahertz, you're asking for a compromise and certainly something bespoke.
Well, here's the Kiwi looking at the same antenna at the same time.
Right.
And here's here's K9Q Web. Now,
if you zoom in around, it'd be helpful.
I can't zoom. K9Q Web is such a feeble program. I can't zoom in anymore.
Oh, okay.
Okay, so that's the limit. What I can zoom on K9Q Web, but and of course the Kiwi allows me to zoom in a whole bunch more. But I don't see a lot more signals here. Again, the K9Q Web doesn't have, I don't know the calibration, the vertical. It has no level. Doesn't output levels.
Well,
so many limitations on this.
I can tell you it's pretty deaf because the signals. If you go back to between 20 and 25 kilohertz, there are quite a few signals that are rather obvious, and those. Those faint lines. Some of those are Europe. Some of them are Iceland, Italy, and all that. Some of them are Russia.
Okay. I don't see the big difference you do, but I think that this is such a limited view that I don't think you should criticize the performance of the 888 based upon K9Q Web's spectral display, which is
but I can tell stuff is missing. I can tell the stuff is missing just by looking at it. It doesn't look right. But
the question is it doesn't look right because of the display or because of what's actually
because I can tell it's because of what's actually coming in there. I mean, but anyway, I
don't want to.
I'm not surprised though because I'm not at all surprised because that transformer is probably not transformer's official low end is probably a meg. Transformer. It's probably a meg. Maybe it goes lower, but my experience having swept these things is usually when they say down to a meg, they're usable a tenth of that frequency, maybe a 20th.
Yeah.
So down to
But what you're suggesting is that the problem is not the using K9Q as in a RX 888 architecture. It's
right.
this transformer in the 888.
Right. I mean, you could change the transformer, or I mean, if you were to, you could design a version of the 888
without the transformer. It seems like.
Right. And
I mean,
mainly the transformer is used between the VGA and the A to D converter, because the A to D converter's natural impedance is hundreds of ohms.
And it wants a balanced input.
Right.
So you have to, and if you have a single-ended input SMA connector, you have to go to from single-ended to balance. So
the A to D wants a balanced input. The easiest way is a transformer, but you could also just use a differential amplifier of some kind. To take care of that. You could use a single-ended. You'd sacrifice some performance. I mean, it wouldn't be hard to modify if you simply took out the transformer and replaced it with the capacitor and another one to ground. I'll bet you it would, or a couple of capacitors. I'll bet you it would work way down. It'd be more deaf, but it would work lower. Yeah. There's nothing wrong with K9Q radio going down to audio. I mean, it doesn't care. It just.
I thought it's so I think it's anyway. It just I just was wondering whether if there's anything architecturally that would make this a properly designed 888 useful at ELF, and it doesn't seem with K9Q radio together.
Well, keep in mind ELF is 3 kilohertz, 3 kilohertz to 300 hertz.
Yeah.
So as I recall, and I mean, RX 888's hardware is not appropriate. I mean, it looks like it's probably okay down to 30 kilohertz, which VLF starts at 30 kilohertz. So it looks like it's okay down, but I can see some roll off. But if you notice on the RX 888 web thing,
they don't specify.
DC is saw that uptick in noise, but that's normal over F stuff.
Yeah.
I mean, the advantage, if you wanted to use it seriously, it would be a super simple board to convert it up to some higher frequency, and then you can just tell whatever program you're using. All right, 0 hertz is really like.
Yeah, of course, I understand that.
Then you could.
But that means you have that. But in any case, I don't mean to belabor this.
No.
I think so. Jonathan, you're showing us the spectrum you're seeing from your ELF system in that frequency range. I see 40 kilohertz. I see a peak at 40. Is that right, Jonathan? And of course the big peak down at 22, Jack Creek.
Jim Creek.
25 or whatever.
Yes. So VLFRX Tools comes with 3 graphical utilities that will allow you to look at the live signal both in the time and frequency domain. So this is VT spec, and what it's showing is the spectrum all the way up to 48 kilohertz. And you can see some jumps in noise, but when especially on the lower end. So the lower end here, this is kind of where your spirits are.
Yeah, and you're not, and that's clearly the 888 transformers rolling off that. We're seeing much less of that noise through the 888.
Yeah.
Well, I from my perspective, it's just one more reason why we need to have our own 888 design, and so that we know what these things are, what these various design parameters are, and
right, yeah, and at least with this, so this is obviously Cutler, Maine, and Jim Creek, and this is North Dakota. This is Iceland here at or no, this is Iceland. This is Puerto Rico. So and also this is the spectrogram at or the spectrum at nighttime. So the amplitudes are obviously much higher than they are in daytime. But yeah, this is kind of what it normally looks like.
Yeah, well, but we're seeing a bunch of the same signals through the AAA, but so it's it just we're just interested in the limits of the architecture. I don't think we have an easy way to. There's no real-time waveform display of the of the output,
right.
G0, the the K9Q web only does the spectrum display. It doesn't have a waveform output, so we can't really look at that. But clearly, it's not it's not looking at the AAA. Clearly is not seeing much below certainly above below 20 kilohertz. But I think I think it's likely. It seems likely that that is entirely a function of the transformer in the 888.
Well, they also use coupling caps that aren't big enough.
Yeah, yeah, and Glenn said that his coupling caps in his receiver are probably high pass filter at 300 or 400 hertz. So I mean he hasn't really looked. To try to extend the low frequency. He was, and I think we're not sure what the Kiwi's response is down at those frequencies.
I checked the Kiwi years ago, and it falls down somewhere below 10 kilohertz, but it's entirely a function of the coupling caps.
Yeah.
But yeah, I mean, if you put audio into the Kiwi and tune it to 0 hertz, you can hear it just fine. It's just tinny sounding.
Yeah.
I mean, you can understand it. I mean, the voice and everything is fine. It's just tinny.
Yeah.
So, yeah.
And a good measure of at least the VLF response is that see this dip here around 1.7 kilohertz and the 2 kilohertz, when the noise settles down.
Yeah.
That dip is the natural filter or mode of the Earth ionosphere waveguide. So usually between 2 to 4 kilohertz, you don't really see much signal at all. So
interesting.
If you're looking at the Kiwi, what you should see is a hump starting at 0 hertz, kind of like this hump right here. This is actually most of the power line noise. And then around 2 to 4 kilohertz, it'll kind of tail off where there's no signals at all. And then after 4 kilohertz, it'll start to pick up. And this is where most of the spheric energy is. But around 2 to 4 kilohertz, it should be tailing off. So if you're seeing that in the RX-888 or the Kiwi, then that means that you're actually seeing the natural modes of the ionosphere.
That's great. No, well, I'm not seeing it on the Kiwi, and it's hard to tell because I can't really zoom in on the 888.
Yeah.
But I'm not seeing it. I see some 60 hertz or 120 hertz lines, but I do not see any clear dip between 2 and 4 kilohertz. So I don't, I think that system, needs changers in order to be able to pick up that stuff. That's interesting. Well, anyway, I've learned a lot from your presentation tonight,
Thank
Jonathan.
you. Thank you.
So, okay, if you'll excuse me, I think I'm going to bow out here. Unless anybody had questions for me,
for what it's worth, that's what I see. I see maybe a little bit of the dip there, but around 1.5 kilohertz. But it was I've never attempted to optimize it below 10 kilohertz. Occasionally, I do see the Russian alpha system.
Yeah.
Over here, but it usually don't see that here in Utah. I mean, maybe early in the morning before it's sunrise, but I try not to remind myself that there's more than one 6 o'clock in a day, so I see it.
Yeah. Okay. Well, I think we could declare this an ELF evening.
Well, I've been unclear. People talk about, the PWSs and whatnot. I've been unclear what role ELF monitoring is saying is. Of course, I need to probably just read the grant proposal that got granted and find out what it says. But anyway.
We're so we're basically looking to capture natural radio signals, whistles, dawn chorus, spherics. We're looking to capture VLF transmitters. We're also looking to capture any amateur transmissions in the VLF band, and any sort of other interesting signals in the VLF band.
So you're talking about the below 9 kilohertz ones?
Yes.
Okay.
Yeah. And the plan is to have a network of these VLF receivers,
right?
Uploading data to a central server.
What it sounds like I probably need to do is throw together a BB3 and wander around the property. We have at Northern Utah. So, and see how quiet it can be when it's devoid of any mains reference.
Yeah, I mean, if you could hear spherics very clearly and the hum isn't really that bad, then you probably have a pretty decent location, and then the mains filter can filter out most of the hum. It doesn't work perfectly, of course, and obviously, if your hum levels are high enough to overload the system and generate harmonics, then it's not going to work, obviously. So, but yeah, if you ever get time to throw that together and test it out, I'd be really interested to know the results.
Right. I mean, I don't know exactly how far the property goes, but from the landowner's perspective, as long as it doesn't get in the way of the cattle and something like that, I mean, they're pretty cool with whatever we're doing.
Okay.
So I can, but yeah, it'd definitely have to be put at a significant distance from the building, and then, solar and wireless, it'd have to be that's doable, but that's the way it'd have to be done.
Yeah.
Just plant it on a post. The biggest problem we have is the cattle, and if you've ever been around cattle, they rub against everything.
Yeah.
I mean, you have to warn people if there's cattle. Don't park it where the cattle can get to your car. Otherwise, you're going to have like dented fenders and door panels, because they're just going to rub against it. When a ton of meat rubs against their car to try to scratch an edge, it leaves marks.
Yeah.
Yeah.
The interesting thing about these VLF receivers, the antennas are very microphonic. So if something rubs the antenna, you could definitely hear it.
Well, So, well, yeah, I mean, our problem out there is well, presumably insects aren't quite enough to do it, but anyway.
If insects buzz around the antenna like very close, like a
Yeah.
maybe less than an inch, you could hear them buzz.
Okay, well, so the landowner told me that that during the peak mosquito and deer fly season, their cattle will lose a half a pint of blood per day.
Wow.
Yep. You don't. I was there. I was there this past weekend, and when it got above about 50 degrees, we had to shut the door of the building because we were getting the mosquitoes were just awful.
Wow.
I mean, this cold, we were surprised. We didn't expect this to be mosquito season. The only time it's tolerable to be out there in short sleeve is when it's in the 40s. Then it's not tolerable to be out there in short sleeves.
Right.
It's a miserable place to be. I mean, people ask, "Can I visit? Can I visit the WebSDR site?" And it's like, well, if you're going to do that, you better wear DEET and long pants and long shirts.
Yeah.
Yeah. But I have, yeah. Anyway, I'll try to remember to put something together and take a listen. I've thought about it, I just haven't done it. But yeah, the existing receive system was never intended to be optimized below 20 kilohertz.
Right. Yeah. Yeah. And I was figuring that too, because I didn't think that the 888 and the Kiwi and others were optimized or worked very well, and so I never really took that to be useful, and I figured I would just stick with the tried and true sound card and preamp, and that's been working great.
I once saw it's probably been the 80s, but I once saw a extremely, I don't know what's below ELF. I mean, this is like below 10 hertz. But the guy actually used lock-in amplifiers commutating amplifiers just to get around the 1/f noise, to get extremely good sensitivity. This is sub 10 hertz, way sub 10 hertz.
Yeah.
But they actually were, I don't think they used flying relays, but they may have, just to, shift the frequency above the worst of the 1/f noise. So, but that's really low stuff. I'm trying to remember the guy's name. I have it somewhere in my ELF VLF files. I have a copy of his doctorate thesis where it's all about designing VLF and ELF receiving systems. I wonder where I have to look for it, but yeah, I think his name was Evans, the guy that did it. But yeah,
rings a bell.
Yeah, yeah. If I say Ralph Burhans, does that name mean anything to you?
I believe so. Yeah.
Okay. Yeah, he would have been. I'm sure. Yeah, he and Ralph Burhans was big into the amateur LF stuff, like the 1750 band stuff, meter band stuff, way back in the 70s into the maybe 90s, I think, when he passed away. But yeah.
Oh wow. Yeah.
Right. So yeah. The lowest I've ever transmitted though is 2,200 meters, which and I was this week I'm planning to get the transmitter back up and running. Just it's actually mostly right here off camera, but
yeah.
But yeah, I don't think anybody has done the VLF stuff amateur around here though.
No.
There's some stuff on 8192. Between across the pond, I know that German There's also some guys doing Part 5 stuff about a decade ago.
Oh, really?
Yeah, there's a guy, Ham in Penn Yan, New York, of all places, that got a Part 5 license. And if you get a Part 5 license, you can pretty much transmit wherever you want. The only thing the FCC says is don't bother anybody else. But the guy was actually sending QRSS 90 at 29 kilohertz.
Wow.
And I was able to copy him here in Utah. And he was using, what was he using? He was using a 1,200 foot long T antenna. You know, it's a top hat Marconi T.
Yeah.
Yeah, and he was able to cross the I was able to receive him. I have the image file somewhere.
Wow. I think there were, yeah, I think there were some other people, maybe North Carolina, somewhere around there, that he was able to get a Part 5 license and transmit around 29 kilohertz.
Right, there's this one Part 5 license. You can get a group, and there's a group of like a dozen hams or something that were all included in it.
Right.
This instance I'm thinking of, I'd probably have to set the Wayback Machine, yeah, to find it on my email, but I believe I emailed the guy and got an email confirmation that this is, you know, like setting the Wayback Machine. I'm just putting Penn Yan into the into my email searching thing, and maybe I don't have it here, but yeah, there's a, yeah, I want to say that was like maybe 2008, 2010 time frame, maybe. Something like that this was going on. It's been a while.
Yeah, there was, let's see. So Paul Nicholson, yeah, so Paul Nicholson did, let's see, there was, yeah, 29 kilohertz. Here, I'll post. So
was he the one in New York, or was he the one in PA or Carolinas?
W4DEX, I believe.
Oh, Dex. Oh, okay. Yeah, I'm on the VLF group, and I think he's still. I think I might have actually worked him on 630 if he's there.
Oh yeah, yeah. Here's the link. Paul Nicholson keeps a list of VLF milestones for amateurs.
Okay.
And you're on the VLF groups.io.
Hello everyone. Hey Clint, how are you?
Fine.
Can you hear me?
You're in and out, but your audio is inconsistent. But yeah.
I can't hear you.
Let's see here. These are okay. Frequency. These. Oh, there we go. Frequency hertz. Okay, I just had to order the list by. I don't see the. Well, okay, it wouldn't have been a milestone. I mean, this is, but.
Well, this was what he captured, of course.
Okay, yeah, I see that there. 22.97 hertz. 3.5 kilometers. Okay, you could almost do that with just electrostatic coupling.
Yeah.
Yeah. I mean, the Confederate kite telegraphy experiment was was just a reasonable percentage of that distance.
Mm-hmm.
Yeah, I've also done a lot of stuff at Lightwave as well. I mean, I've been to both ends of the spectrum.
Yeah.
My distance on that is 173 miles.
Wow.
We're using LEDs. Lasers don't work over that distance. I mean, lasers are terrible when you get more than a few kilometers through the atmosphere. But yeah, let's see here. But yeah, okay. Just probably take a bit of researching in my email to find the logging of that, or the reporting of that stuff from the Part 5 stuff from way back when. It's weird to think like 2008 was way back when, but
yeah.
Okay. Anyway, all right. Okay. I'll add. Well, I'm thinking about I need to add VLF RX to my list next time I go up to the Utah SDR site. It's about an hour and a half drive from here.
Yeah. I wish I could join you, but I'm in Pennsylvania, so.
Oh, what part? I lived
northeastern Pennsylvania.
I lived in State College for a couple of years.
Oh, cool. Okay.
Actually, not State College. It was Pleasant Gap, which is I went to Penn State for a couple of years. So
yeah.
But Pleasant Gap is a little village north. I don't know, about 8 miles north of State College. So.
Oh wow.
So yeah. Yeah, I remember at the time if I wanted to watch Star Trek Next Generation, the only choice was the Wilkes-Barre PBS station. Very snowy.
Yep.
And it had no commercials.
Yeah.
Because okay. Let's see. VLFRX test. Okay, I'll add that to my to-do list here. Yeah. I didn't do too much LF stuff in State College, though. I did some microwave and some VHF and UHF stuff, but never.
Yeah.
Never on the low end.
I've the only thing that I've done in microwave was C-band and K-band satellite.
Yeah, it's let's see. I've both a homebrew 10 and 24 gig transverter. But let's see here. I'll bring up what my. It still looks this way. It's actually a bit more cluttered, but this is my 10 gig transverter.
Oh.
Yeah. Yeah, I've worked like 60, 70 miles on it, no problem. But it's narrowband. And there's a power amplifier that's not included in this that's kludged in right about here.
Yeah.
Power amplifiers, and it's good for 3 watts, but I can't drive it to produce more than 100 milliwatts. But yeah, I use an FT817 for it with it. But somebody emailed me years ago. There's apparently a Reddit thread on that started out, can I get ham gear through TSA? And it started showing, people started talking about, yeah, no problem. But then it devolved, as Reddit does, to things you might not be able to get through TSA. And somebody posted this very picture saying, you might not be able to get this ham rig through TSA. And I can't say I disagree. But yeah, I've since added a way to couple it into a. I think let's see. Does that? Yeah, that one has. Yeah, that I've added a way to couple it to a rubidium reference, which is helpful.
Mm.
But anyway, so anyway, probably it's midnight where you are, isn't it?
Yeah, I actually have to get to bed very soon because I have to be up for work early in the morning. But you know, it was really good. It was a good talk. That's why that I wanted to.
Right. Okay. Yeah, it's good. I haven't. Yeah. I mean, it's. Yeah, I haven't really thought about McGreevy for a while, but yeah. Is he still in California?
Mm-hmm. Yeah.
Okay. Yeah, but yeah, I used to get on the. I still check into most Saturdays. Check into the. It used to be the loafer 80-meter loafer net, but now it's just 80-meter LF net or something like that. You know, a lot of 630 and some 2200, and of course Dave Curry, WD4PLI. I don't know what he used to do with, but he used to hang around with Steve. I believe, you know, he's in California.
Mm.
But I know I know they know each other and they've met a bunch of times, but he still hangs around, but he's big into 1750 still.
Mm-hmm.
So anyway, I'll let you go. I need to run too. So see you next time then.
All right. Yep. And oh, I also posted. Well, you're probably a member, but I posted the link to the Groups AO BLF group.
Oh, I'm not in that. Okay, I'll open the link and okay, now it's in my browser and I'll add myself to that. All right, thanks.
Yep.
All right, I'm gonna bail out. See you, everybody.
All right.
Bye.
Bye.
All right. Thanks again, guys.